Okay, so I'm going to talk about calculations of chemistry in this video. This is an example from CCEA Chemistry GCSE paper, but these very similar questions come up in CCEA GCSE single, double, triple, plus AQA or any other exam board all have very similar calculations to this. So first of all, you can see that calcium hydroxide reacts with carbon dioxide according to the equation. So calcium hydroxide plus carbon dioxide, CO2, gives calcium carbonate, CaCO3, plus water. And I tend to look at the equation, first of all, read the question, make sure that I'm happy enough with what is reacting, what is being formed. I know what each of those are. Part 370 grams of calcium hydroxide were mixed with 308 grams of carbon dioxide, and it's given you your relative atomic mass for each of those as well. So the relative atomic mass can be represented by M with a little subscript R, or RFM. And I'm just going to put the masses underneath the equations here. So we've got 370 grams of calcium hydroxide, and that was mixed with 308 grams of carbon dioxide. We don't know the mass of the product yet. We're not being asked about those yet, so we'll not worry about calculating those for the time being. So we know we start with 370 grams of calcium hydroxide. The question then is asking us the number of moles of calcium hydroxide in 370 grams. So you have to convert from mass to number of moles, and there is an equation for that. You may have learned it as a triangle. Its number of moles is equal to the mass over the molar mass. Now, you might not have called it molar mass in your school. You might have called it relative formula mass, relative molecular mass, relative atomic mass. So you can use any of those different names. RMM stands for relative molecular mass, or AM for atomic mass, or relative formula mass can refer to atoms or molecules. So that's probably the better general one to go for. As I said, you might also have discussed it as big M, little r, like is shown in the question there. So calculate the number of moles of calcium hydroxide. We're going to use the equation, moles equals mass over molar mass, or RFM. So it gives us the mass, first of all. So we look at the mass, substituting that in there, and it's 370 grams as given to us in the question there. So 370 grams, and the RFM again is given, so that is 74. So 370 divided by 74 gives us the number of moles of calcium hydroxide that we have that have been added to this reaction. Okay, type that into your calculator, 370 divided by 74. And that gives you your result in mole, which is the unit for moles. Okay. Okay, so that divides exactly to make 5 moles there. So now we know that in the reaction vessel, what we've mixed in, 370 grams of calcium hydroxide, is the equivalent to 5 moles. Now the next one, feel free to pause the video here and try this yourself. So the number of moles of carbon dioxide in 308 grams. Same equation, moles is equal to mass over RFM, or molar mass. The mass is given there, so it's 308 grams. And that is divided by the RFM, which was given to us above, which is 44. It's 44 because carbon has a mass of 12, oxygen has a mass of 16. You've got 2 oxygens. You add those all together to get 44. Put that into your calculator, and you'll find that it is 7. So we have 5 moles of calcium hydroxide, and we have 7 moles of carbon dioxide, which means we've got more carbon dioxide than we need. If you think about it in terms of a recipe, you need 1 portion of calcium hydroxide to react with 1 portion, or to mix with 1 portion of carbon dioxide to produce calcium carbonate, 1 portion, plus 1 portion of water. So if you're scaling up the recipe, if you're starting with 5 portions of calcium hydroxide, then you can produce 5 moles of calcium carbonate and 5 moles of water. So although you have 7 moles of carbon dioxide, you don't need 7 moles. So you're only going to need 5 moles of carbon dioxide to react there. And the other 2 are left over. You can think of them as men and women if they're doing some sort of traditional dance. There are 2 that don't have a partner, so we'll ignore them for now, but just so you know that they're left over. So calculate the moles of calcium hydroxide. Sorry, I'm going to ignore that question. I'm just going to work out how many moles of calcium carbonate you can actually produce there. So we know we can produce 5 moles of calcium carbonate. We're given the RFM of 100, and we can actually use our moles equals mass over molar mass equation to work out the mass of calcium carbonate that are produced. And that is a common question, though it's not asked here. You might have learned this as a triangle. A triangle can make it a little bit easier to rearrange equations. Of course, you'll have done rearranging equations in maths by GCSE, so if you've done that already, then that's totally fine. Sorry, my drawing isn't very clear there for my triangle, but if you've used triangles before, you'll know that whatever goes on top, you multiply it by the 2 things on the bottom. So mass is equal to moles times RFM. So if I want to find out the mass, you can rearrange that equation and find mass equals RFM times moles, or moles times RFM. Now we know the number of moles because we've used our ratios. The recipe is 1:1:1:1, which means with 5 moles of calcium hydroxide, we can produce 5 moles of calcium carbonate. And the RFM is given to us, 100. So the mass is going to be equal to 5 moles of calcium carbonate multiplied by 100 grams per mole. So the RFM is 100. Put that into your calculator, and you'll see that we can make 500 grams of calcium carbonate using 308 grams of carbon dioxide and 370 grams of calcium hydroxide, although not all of the carbon dioxide will react, as we discovered earlier. Okay, so another type of question that you might be asked about is how to calculate relative formula mass. So relative formula mass is just the sum of the relative atomic masses that are given to you here. They're also the mass number in your periodic table. So if you think about sulfuric acid, if you were to put all of those atoms on a scale, 1 mole of hydrogen would weigh 1 gram, but you've got 2 moles of hydrogen there. You see that little 2 beside the hydrogen. So because you've got 2 moles of hydrogen, if you put them both on a set of scales, you'll have 2 grams in total. But to make sulfuric acid, you're also going to need to mix it up with a portion of sulfur, or mole of sulfur, and 4 moles of oxygen. So to get your relative formula mass, you have to add all of those together, and that should give you your answer. Okay, so for the next one, you'll see that there are some brackets involved. So if you see things in a bracket like that, 4 inside the bracket and 2 outside the brackets, so you know what's outside of the brackets has to be done to everything inside the brackets. So in maths, if you have something like a to the power of b all to the power of c, you have to multiply b times c to find out what a will be to the power of. So it's similar in chemistry. We're going to multiply that 4 by that 2. Now the nitrogen is also being multiplied by 2 because it's also inside the brackets. So overall, you've got 2 nitrogens. You've got 4 hydrogens inside the brackets, and that is all being multiplied by 2 because there's a 2 outside the brackets. So overall, you have 8 hydrogens. Now, once you've got that information, you should be able to count up all the atoms, all the atomic masses of all the atoms used to make that molecule, and that will give you the mass of the whole molecule. Feel free to pause the video here and try it, and I will show the working out momentarily. Okay, so 4 times 2 is 8. 8 hydrogens, they all have mass of 1, so that's why I'm just writing 8 there. Carbon is 12. Oxygen is 16. Sorry, that's a little cut off. 16 times 3 is 48. So if you add 48 at the end there, then in total that works out as 48 plus 48, 96. Okay, so hopefully you understood that.